The following program is an oral assault on the ears, yet again, thanks to the crappy camera. Here's a tip. Don't buy the Insta360 camera unless you want your videos to all sound like they're underwater, because this thing won't tell you when its microphone adapter has arbitrarily decided not to bloody bother.
Hello, it's David at disinterested UK, and today I am talking LED lighting conversion, something I mentioned in a video in July. So we were going to be doing this job. In fact, I said Linda and I were going to be doing this job. Unfortunately, Linda's been taken ill. Go off soon, Linda. So don't worry. I do have glitz and glamour for you. Oh, I tell you what, the perverts who watch this channel can almost hear them zipping their flies back up right now.
Yeah, unfortunately, I'm no replacement for Linda, but I'll try my best.
Linda is irreplaceable, but yes, I'm sure someone's still got their hand down the trousers.
I'm playing apprentice. Playing apprentice today.
So yeah, yes. I'm in your neck of the woods, Kevin. I've left the 30 Celsius sun of Leamington Spa to drive 2 hours up north to.
That's it. Dewsbury. Well, sunny Dewsbury. Should we call it sunny today?
Permafrost Dewsbury. So yeah, I wouldn't normally get out of my way, but
interesting job.
We do have an interesting, we have a relevant job, because as I say, there was a video in July where we were talking about how the LED lighting industry has let us down by pumping out poor products to be put in place of where traditional fluorescent, incandescent, SON discharge lighting was perhaps in use. And the whole emphasis of the EU and UK legislation being thou shalt save energy, but not putting anything on the manufacturers about thou shalt actually make stuff that isn't shite and will last more than 6 months. I was running in that video about Lekiko, Leseco, Lesico, however you say them. I wasn't just moaning about them, I was praising one of their products as well, because they make some crap products, they make some good products. We're not going to be putting in their products today, but we are going to be putting in something that's similar to what Lekiko, Lesico, Leseco make. Who would work for a company with an unpronounceable name?
I don't know. I
don't know. Where we are, of course.
Well, exactly, yes.
The T-shirt you have to give away.
Gives it a bit of away.
The
logo.
That we are in the depths.
That's it. We are the headquarters.
Chauvin Arnoux.
Chauvin Arnoux.
You seem to be popping up at the murky end of YouTube on all sorts.
We seem to be getting involved with some really dodgy characters at the moment. So
obviously, Artisan charges too much for your services. Here you are, slumming it with the likes of Ursan, slumming it on things like Electrician's
Podcast as well. So
a venerable manufacturer.
Yes.
Jumping in at the shallow end.
At the interesting end, I'll call it.
Okay. But we are going to be doing something interesting today, because we are here. This is not only your impressive looking studio, you will see more of that on Kevin's own YouTube channel, linked in the description, where he shows off some of the wares that you produce. Yeah. Lots more videos to come.
And lots more videos to come, yeah, we've got a very busy August planned.
Yes, indeed. Yes. So we've got the studio set up there, but also what we have here is your warehouse, isn't it? But what we're concerned with here today are the rest of the lights, and as you can see above us, we are looking at fluorescent T12s.
T12s, 8-foot T12s.
2400mm. Oh, that is quite
big boys.
A length. So what we're going to do here is a conversion job, which is what we spoke of in the last video, where we showed a Lekiko, Leseco, Lesico, how you pronounce them, product that we like, because you can interchange the tubes. So what we're proposing to do here today is a conversion of these buttons. I'll tell you what's handy about being with an equipment manufacturer is if you need a bit of kit, they've got them on the shelf.
We've got a lot of them.
Yeah, we're starting off with the CA 1010 lux meter.
Yeah, nice bit of kit actually. Nice bit of kit. It's a logging lux meter.
I say.
So we can actually leave it for a period of time, and you actually get logging and mapping over time, so you can actually see how it varies throughout the day or the week or whatever you want to do. It's even got the option for LEDs and fluorescents, so it will work on the frequency ranges from those. So it's quite a useful function.
I think this sort of thing, it's important to have something that's got a high degree of accuracy. I'm sure that I've seen cheapo ones out there, and you kind of think, okay.
Mentioning no names, but yeah.
Is that really going to give me the level of accuracy? If it's not accurate, what's the point? What's the point? This is a big thing at the moment, of course, because like it or not, the EU and the UK have come along and said, thou shalt not be fitting any more T8s, or obviously the T12s are already out. So when you're in a situation like this, you've got to do something about it. There's an awful lot of offices, warehouses and other commercial buildings out there, I'm sure, who have no idea that this is coming
No.
and are going to get caught out very soon with massive lighting replacement bills. As a community centre we look after, we've been telling them for ages that they need to, the lighting's all 20 years old, it's fluorescent, it's all pretty knackered, to be fair, and they keep paying us to go in and maintain it. They should be paying us to go in and sort it at this point, because especially while energy prices are high, the sooner you do it, the sooner it starts earning its keep. And with the LED stuff, it's all about putting in the right equipment, not putting in rubbish.
Yeah, I mean, not so much from a domestic point of view, but certainly from a commercial point of view. The CIBSE guidance, the Chartered Institute of Building Services Engineers, actually the lighting levels. It's quite hard actually when I was going around here doing some initial logs of trying to judge, you know, areas that you thought were dark actually complied, areas that you thought were bright were maybe too bright.
You've done the offices, of course. You've got your LED panels in there. Did you find that it was a one out, one in conversion, or could you?
Well, what we did was a 1 out, 1 in conversion, and when we looked at the levels, actually, I was looking at the levels the other day. Actually, we were way over. You know, we're sort of talking 1,200 odd lumens.
You know what you should have done? You should nicked one of these off your own shelf and gone around with it.
We should have thought, shouldn't we? At the time, you know, these things are, you know, there. We just didn't really. We just did a like for like conversion, took out the fittings that were there, replaced them with the panels, and actually, yeah, we could have got away with probably half the panels.
Yes, so of course that saves money, saves maintenance in itself, in that it's not necessarily a case of changing each point in these commercial environments, but using equipment like this to make sure that you're putting in something that's fit for purpose. I remember working in an office a few years ago where we had to get the maintenance guys to disable the light above our desks because it was just too bright where we were working, too reflective off the screen. I don't like a bright room. I know some people do. I like to sit in the dark, and that's what my eyes are used to when I'm staring at a screen. I don't want a lot of light, a lot of reflectivity. Obviously, this is a different area here. This is a working area, a warehouse area. What we're going to do now is we're going to take this lux meter, we're going to stick it beneath the fluorescent light that's there, and we're going to just take some readings from cold just to see what it's doing, see how it is after it's warmed up, and when we have finally done the conversion, we'll see how that compares to the LED tube that we'll be putting in place. Exciting times.
Exciting times.
78, 79 lux. We expect that to climb up, as indeed it is doing. Try not to block the sensor with my camera there. As it warms up, it'll take a couple of minutes to get to full strength. But what we want to see is what light level we're getting from this luminaire at full strength. It's the only one that's on the moment. And these two, I'll take a switch separately from the rest.
Yes.
Yeah, that's fine. That's actually quite good because that is just giving us this test point here, isn't it? 125 and climbing. And you found some figures, didn't you, for a packing area on the...
Yeah, the CIBSE guidance was about 100 lux for a general warehouse, and packing areas was about 200.
Okay.
And when I did the log on this the other day, which bearing in mind I left it on overnight, it was about 240. So we're still quite a way under that at the moment. Just an interesting aside, Dave, while we're waiting for this to go, I did log overnight, and what I actually saw was a dip at 10:48 in the evening. There was a dip in the lighting levels, just a small dip in the lighting levels.
Okay.
And I couldn't figure out why it was. But luckily I was logging with the PEL 51 on the voltage at the same time, and there was a voltage sag at the same time.
Okay.
So actually the voltage actually did have a notable effect on the fluorescence lighting output, which is interesting.
Indeed so. We should be playing with the PAL 51. Another thing we want to look at before we start work here is how much power is the existing lighting taking, and we appreciate, of course, that there's a fair few that are out of service, so we can compare that to what we're pulling once we've completed our conversions, but also what the power factor is, and whether the power factor is about the same or improves with the LED stuff. So that'll be interesting to see. While we're waiting for that to climb up, and they're still around.
That's you.
It does show how sensitive that is, though, doesn't it? You only have to sort of get close to it, and it really does pick up that difference. So this is what we're putting in. Fusion T8 LED tube. Energy rating F on a new scale. And again, I'm quite surprised at that, but I suppose they've had to leave a good bit of leeway at the top end of the scale for future improvements, because it all got a bit ridiculous with the old scale with their A+, A++, A+++. Kept having to break it down further, didn't they? So I presume that a lot of the off-the-shelf LED lighting you're going to get today is going to be sort of the DEF range, potentially, because they've probably left a load of leeway.
Yeah, and I'm guessing there could be some size considerations with what they have to pack into the sort of the package, for want of a better term. So if you actually had a replacement luminaire, there might be more room for sort of spreading the LEDs out and a bit more electronics maybe in there.
Again, we didn't want to get into, because you've got, for example, the conduit around here, changing that out is going to be a more mechanical task, and you're not going to get something that same size, so we were quite keen to keep the battens in place. We can also say about this thing that, what can we say about it, 3,900 lumens. Now they say that a fluorescent tube this size can put up to 5,500 lumens, maybe when brand new, probably not when aged somewhat, but it's a moot point anyway if you can't get the things anymore. 200 now, so I mean, that's got to be a good sort of 4 or 5 minutes.
Interesting. You don't, without a lux meter, you just don't know. You wouldn't really be able to quantify these things, would you?
I'd have assumed that would have got up to temperature sooner, but there you go.
And then we're actually seeing what looks like 2 hotspots where they actually have 2 chokes or 2 somethings in this fitting. So we'll have to investigate that a little bit and see why we've got.
That's a bit weird, isn't it? I expected 1 ballast per fitting, 1 choke. I'm not sure why there would be 2.
There's definitely
a luminaire that's only got 1 floor.
Yeah, it's definitely two hotspots, sort of about a foot in. Well, say a foot in from each end, something like that.
Interesting that, because like you say, 2 heat sources. Why?
Yeah, it's consistent with every one though, so there is something inside each one. So
it turns out these fittings do indeed have 2 ballasts, which is why we were seeing 2 heat sources, each about 30 centimetres inside the case from each end. Presumably trying to make a single ballast with the balls to drive a 100-watt tube would have been too big for the casing, but combining 2 ballasts in parallel did the business. Pretty swifty.
Okay, using the HEL 51, hopefully there's a video about all this on the channel by now, and if there isn't, or even if there is...
Yeah, check out the Chauvin Arnoux channel, there's plenty on there.
Linked in the description. These lights were split over 3 circuits. We've watched them all into one using a Wago connector. There you go, we've got the CT wrap around that. Taking the voltage from that breaker, that's now serving all the lights. I don't know what the lights are out of service, of course, at the moment. We haven't had a count yet, have we? We should go
no, but there is probably at least 5, I would say, are probably out of circuit. So
pulling 1.76 kilowatts. What is our power factor doing? 0.96. Wow. Looking at the live data there, wow, it's 0.96.
Still very good.
Yeah, wow, but much better than I expected.
Says a lot for these old Thorn fittings, I think.
Well, that's it, isn't it? Bulletproof things. What I'm going to do, actually, is I'm going to tell it to record a session. So we're going to leave that recording for 5 minutes. We'll go and have a little count of what's dead while it's set up to record. What we'll do once that's finished recording is we'll just take a look at the graphical data. There's not going to be much graphical data because it's obviously such a short recording window. Let's have a little quick count while that does that of where we are in terms of what's working and what's not in those rooms.
So there's 1 there on that circuit.
1 missing.
1 missing. What have we got? 1, 2, 3, 4, 5, 6. So 7 out of 24. So about a third.
Yeah. Just a very quick and dirty 5-minute log of that lighting. What we got here is, again, it's a surprisingly high power factor. Well, surprising to me, maybe not surprising to anybody else. I expected it to be worse than that, but like you say, must be decent.
I'll take it,
Yeah. I've certainly seen worse on fluorescent, but like everything else, I suppose, you get what you pay for. Yeah. If you pay for decent fittings. So our true power, wow, what do you make of that, Kevin? It's obviously we're zoomed in on quite a small scale here, so it
looks like actually pretty stable, really.
Yeah, it looks like it's fluctuating a lot more than it is, but you've got to appreciate that our scale is only going from like 1.74 to 1.78 kilowatts.
Yeah, so it's just up and down by a few tens of watts.
Yeah, reactive power. Again, we're zoomed in on quite a small scale. Looks like someone's about to have a heart attack there, doesn't it? It would be interesting to see how this stuff looks when we plumb in.
Yeah, I mean, this is very much the before data, isn't it? So
yeah,
it's Nigel's favourite toy.
It is Nigel's favourite toy. It's his R2 Honda lead with digital counterpart companion. What we can do here, obviously with all these fluorescents around, these metal battens, We are going to be doing a proper R1, R2 test, but not until we've started taking it all apart. Which, with 30 metres of cable, which is going back to the earthing terminal there, and if you would like to touch the metalwork of that light.
I will try my best. I will try my best to get a connection somewhere. Let's see if I can get onto the case in there. And
there you go.
looks like we're in.
We are proving continuity. We know that there's a circuit protector.
So before we start messing about with them, at least we're sort of forearmed a little bit anyway.
Yeah. Now our pointy stick doesn't quite have the reach to get to those bad boys up there. So again, we're going to have to just do that on the fly, I'm afraid.
But certainly for these ones down here, we can give them a once over with the lead and just check that at least we've got some CPC continuity anyway.
It's all good stuff, mate.
My super assistant and I, we're fairly balls deep into changing these that way. I think we got it down to a bit of an art, yeah, a bit of a tea. So we're just going to go through how long it takes to change one. I'm going to use my stopwatch. Why not? Have a stopwatch. Shall I use it? Out comes the T12, and off comes the cover. Yeah. A few flies and cobwebs and things. Out comes the starter. And off that goes. My assistant here has one fuse ready to go in. So that's jolly good. Tester set to ohms, because we've been doing our R1, R2s, we've been going along. These 3 separate circuits that are controlling these lights. So we've been IR testing them as we get them back on. Doing our R1, R2s as we go along to make sure every fitting is earthed as it ought to be, because obviously these are class 1. The probes in can be a bit of an art. 0.68. Super duper. And these are quite straightforward to convert. First of all, I'm just going to pop out the cable, the wires, right, that go to the capacitor. It's like a sprung connector, which is a pain in the arse. Some of them spring really easily, but when you get the video camera out, yeah, it doesn't want to play ball so easily. There we go, there's one. And there's 2. So that's the capacitor adder circuit. We can chop off the ends of those. We're also going to chop this brown wire, which goes from the capacitor to the second choke. I'm going to chop all the cables going into that choke, in fact. We don't need that brown wire anymore. I'll be that in a second. I'm just going to take this white wire. This is going to be our new power feed. That gets chopped there and connects to our line in. Bit of copper there, that just needs to be out of the way. That's a push fit connector already in there, so that simply pushes into place. And these chopped wires get left out of the way. And then the final task is to take 2 of the wires that were going to this choke, the grey and the white, which is the other end of the white that I just connected to power. Where is it gone? I'm just going to use a Wago connector to hold them together. And hopefully, if future Dave is diligent enough, he's put some pictorial representation on the screen throughout all that, so that you can see exactly what's been done and why and how it works and all that crap. So that's us good to go. And there is one other modification that we've decided to make, and that's to put a T8 hook halfway along the length of the batten, so at 120 centimetres. The reason for that being that these 2400mm tubes are a little bit saggy in the middle, aren't they? I mean, so are you and I these days. So, you know, it's something that gets to us all eventually. But Kevin rather cleverly sourced some T8 clips, which he got shipped in overnight. And, well, they take the droop out of your sag, don't they, Kevin? It's arguable whether that's really needed or not. I mean, the Fusion who make them, it's a shame that they don't make them with a bit more rigidity in them. I mean, they know what they are. They know that they're going to be hanging from something like this. So, yeah, would be nice if they had a little bit more rigidity to them. They are plastic rather than glass, aren't they? So it just looks a bit noticeable.
Yeah, you do wonder on a hot day as well, don't you?
You do kind of wonder, yeah, if on a hot day or even a cold day for that matter, if there's any kind of expansion, contraction, is there a chance they might pop out of the tombstones? Probably not, but better safe than sorry. And I think it looks for a neater, more secure installation. I'll tell you what, 4 minutes, 49 seconds.
Record.
That's not the first one we filmed, but that's most. The other ones we filmed, we didn't put the clip in, didn't we? Yeah. And some of them take longer. Some of them take longer than others. It depends on the fitting itself and how it's hanging. These ones that are more rigidly structured are a lot easier than ones that are hanging on chains. But as you can see, it is a quick conversion. If you were buying a new Luminaire, a 1800mm is probably about the biggest you're going to get. For the most part, then it's not going to be the same sort of footprint. You are going to have to do some messing about, some mechanical work to get it into place. And I don't think you're going to do that in under 5 minutes. I think you're in for a more complicated task to take this whole thing down and to put a whole new luminaire up. And again, the nice thing about these, this tube fails. Kevin here goes and clambers up a ladder and sticks a new one up. Super, right, well, there's only a couple more left to do and then we can hit the pub, Kevin. Kevin, never one to be shy of a shiny toy. We saw previously the CA 1954 thermal imaging camera, and there were a couple of hot spots on the chokes previously.
Yeah, there's virtually nothing on the actual fittings themselves, on the light themselves.
You're basically talking near room temperature, aren't you? It's like
You
23,
are,
24
yeah.
degrees Celsius. So this is a July day. It's not super hot in here, but I'm sure it's warmer up near the ceiling there.
Yeah, if I remember right, the ends we were getting sort of 40, 50 degrees or so towards the ends, and we were certainly getting the two chokes were...
Tell you what, Kevin, it's a thing of beauty, or at least...
What a job. What a job.
It is now that it's done. The trouble with a repetitive task like that, even though it's fairly straightforward per luminaire, it gets a bit boring after the 16th one.
Yeah.
I'm really rather pleased with how it's turned out. I think that, they're pretty sharp looking.
It's a really noticeable difference, isn't it? The colour of the light, the sort of crispness.
Yes, it is a brighter day here than it has been in snowy Dewsbury for the past couple of days. Just wander over here a little bit. But even so, this area where we had at least one duff lamp before, was it two? Yeah, it's got a clean, even light. And we were saying, weren't we, that one of the differences you notice, one of the things we were a little concerned about, is a fluorescent tube obviously has a 360-degree throw of light, and some of that is reflected off the ceiling.
Mm-hmm.
These are very much more directional, much narrower beam angle on them. So they are throwing light where they need to be, but it does make for a darker ceiling, which if you're used to the ceiling being brightly lit, might feel a little more claustrophobic. That's the only
it's definitely a difference. You can see that it is very directional, the beams, aren't they? In fact, they're actually sort of, they've got a reflector at the back, really, haven't they? That's it. There's literally nothing going up, is there? It's all pointed downwards.
Yes. I think they look good, though. I'm really pleased how they turned out. I know we were playing with the light meter before, and we were reading about 300 on the bench here.
We're actually up to 360 odd if we step back, probably.
Yeah.
a bit more.
370-ish. Much better than what we were getting
before
previously.
Sort of 200, 230, 240 on a good day. So
yeah, and you've got to remember as well that these are instant on. In fact, should we show an instant onage and offage?
Yes.
Yeah, no warm-up time, flicker free.
Straight up to 370.
Bing, bang, bong, and 370. Super. Let's take a look upstairs, shall we, Big K?
Yeah.
Exciting. But again, what a difference up here. You can really see a crisp, clear and even spread of light. What sort of numbers are we getting on the?
Yeah, similar to downstairs, really, Dave. I know we've got some of these skylights, which will make
Yeah, there's a bright day.
You know, if we stay away from the skylights, we're doing similar to downstairs. I mean, under the skylights, we're up into over 1,000.
Obviously, you'd have to really check it at night. We have got some studio lights over there as well, so we're going to be dicking around on the bench. But you can see that's a hell of a difference. And in terms of waste, well, we've got a bunch of tubes, half of which were duff anyway. They're going to be going back to Warwick with me to go into City's recycling container. And we've got a bunch of cardboard and plastic bits and starters. Well, they are what they are, really. Obviously, the cardboard can also go into City's scrap bin. The plastic is perhaps a little less recyclable, but
there's not that much of it, really.
It is just packaging waste, isn't it?
Well, if you think there would have been, 24, 25 lights actually going to scrap.
Yes, and even if we had bought brand new luminaires, you'd still have packaging waste for what they came in. So, we have, I feel, got an effective solution here that has minimised waste as much as possible and maximised the potential of what is already on site. And I think if we're going to look at some energy numbers on the PEL logging in a minute, because we took some before readings. And you've got to remember those before readings were with a lot of luminaires out.
Yeah, it's about 7 out.
Well, it'd be interesting to see what we're recording now, won't we? There is a risk with some of these older fittings that you might find the tombstones are a bit knackered. We found these fittings aren't as old as I thought. No. They're dated from year 2000, so 23 years. They don't seem to have suffered from any degradation.
They've been changed much.
No, and they were good fittings in the first place, weren't they? They were Thorn popular packs. They were a good standard of fitting in the first place. Yeah,
and I think if you look at the lighting spread, it's a pretty good even. There is quite a few luminaires, but we've got a reasonable lighting spread.
Indeed.
There doesn't seem to be any sort of banding or big dark patches or anything like that.
No.
So I think it's quite a good quality of light.
It's got more space than he needs.
Well, we can always fill space. We can always fill space.
Right, well, let's go over to the exciting CA studio and just have a little bit of a play of a couple more things.
Yeah, just a bit of a detailed look at a couple of features.
Yeah, just to bore you further. Wow, we're actually in the CA studio space.
Well,
I'm honoured.
If you've got a studio, might as well use it. It'd be rude not to, wouldn't it, really?
Wish I had one, but excitingly enough, and it is jolly exciting, we've got the PEL 51 downstairs that's monitoring all three of these lighting circuits.
Yeah.
We botched them all together just for the recording of our
and we're
energy.
Connected to it via Wi-Fi.
We are connected via Wi-Fi. That's a jolly good thing, isn't it? So that's all the way downstairs. We're all the way up here. You can network those things as well.
You can.
And view them remotely and that sort of stuff. So I'm going to cut to what my screen is showing on my Superior Lenovo here. And we can see that we are pulling in 238.6 volts. And all our lights on here are now only dragging in an amp. An amp. It was about 7.3 or something
and that's
previously, and that was with half the lights out. Well, not half of them, a good chunk of them out.
And that's 24 fittings, isn't it? 24 total.
I believe so. Yeah. So that's not bad going at all, isn't it? If we look at the phaser diagram, what's interesting here is that we're now capacitively loaded. Obviously, ideally, our blue line and our red line would match up.
Yeah.
As they would if indeed these were incandescent lamps. Previously, and I'm not sure we captured it previously, when we were looking at the fluorescent lights, our blue line would have been in quadrant 1, wouldn't it? So the top right there, which would have indicated an inductive load. And I can prove that. I can prove that because what we did do the other day before we made any changes was we did a 5-minute capture of our fluorescents, or the ones that were working in use. And if we switch to that captured data, we can see that our KVAR readings, and again, I know they look like they're jumping about a bit like someone's having a heart attack, but we're zoomed in on a very small scale here, and that was because the power factor of the fluorescence was actually pretty bloody good, wasn't it?
Yeah, it was very good. Those Thorn fittings were surprisingly good.
It is jumping around a little bit, but we are reading a positive value there, so that we know that is up in quadrant 1 there, that is inductive power.
Yeah, so we're seeing positive numbers basically in there, aren't we, with the KVARs?
Whereas on our LED lights now, here's our 5-minute capture from today.
Yeah.
And again, look at that scale. That's just tiny, it's really zoomed in, but it's now negative. So
There's very little reactive power there, but we are in the negative numbers now, so we can see that we are capacitative.
which makes sense because
Yeah.
we're down here now. We're pointing in a downward direction, you might say. If we do look at the live PQS again, our power factor it's probably not quite as good as it was with the fluorescents, but it's not bad at all, is it?
Yeah.
So it's certainly around the same sort of mark as it was before. I think we might have got something like 0.96 or something before. I can't quite remember now. Surprising again with these fluorescents. I really expected that to be lower. Really expected it to be hovering somewhere near a 0.85 or something like that for that all those older fluorescents. But again, it was quality gear. This data here, this shows you, what difference it's made. Not only are now all the lights illuminated, a seventh of what they were pulling before.
Exactly, and it's the difference between theory and reality, isn't it? These are actual measured figures where we'd sort of thought, well, it should be better, it should be this, it should be that. You can do all the calculations and look at the manufacturer's figures, but really having the data there, having the lighting logs and all that sort of thing just proves it, really.
Yeah, and you can use that information to work out your payback period. If you know what you're paying per kilowatt hour and you've got a figure for how many hours the lights are on for, then you can look at that raw data and start figuring out how soon this is going to start paying back for itself in terms of its material costs, and some idiot to turn up with a tower changing each one of these.
And we will do in the future, we will do more logging to actually look at the energy usage and actually get a better idea of the the sort of real world payback on it. But it's good to look at.
Super stuff. The only question is, are they going to last?
Well, we've got a couple of spares, but that's over to you, Fusion. That's on Fusion now. That's out of our hands.
And I think we've said before, and you can't think of this technology as consumable like you do with a fluorescent tube, like you do with an incandescent lamp. It fails, you chuck it in the bin or recycle it, or do whatever you're going to do with it. But this stuff, you really do have to treat it as an electrical appliance in of its own right. And if the manufacturer, Fusion here, say we're going to stick a 3-year guarantee on it, if they start popping off before 3 years, take it back to the manufacturer, take it back to them, make them change it out. It's the only way these LED lighting manufacturers are going to learn, isn't it? Now, I think we're pretty safe with Fusion because they've been a pretty reliable brand for us in the past, but only time will tell, really.
And I'm guessing if there is any duds, they'd probably go relatively quickly or not at all, really, from that side of things. It's usually the case with electronics, usually.
Hopefully, Hopefully, if something's not been made brilliantly,
or got knocked around,
that cap's going to pop, or that poor solder joint is going to give up sooner rather than later within the product's life, so that you get that sort of heads up that it's not great. A couple more things to play with, Kev. A couple more things of interest.
To have a look at. We were talking there about the power factor and actually saying that the old fittings had particularly good power factor. But actually, we've took out a couple of the capacitors just to have a look at what's going on, and actually we found quite a bit of a difference, haven't we? So what we've got is actually these should be 8 microfarad capacitors plus or minus 10%. So one of the first ones we actually pulled out and tested with the Chauvin Arnoux 5277 multimeter.
Ooh, that's a sweet bit of kit.
Nice bit of kit. Obviously has the auto capacitance range on there, and actually this one was only reading 2.1 microfarads. So there's obviously quite a bit of a change from the original tolerance.
Yeah, and obviously the point of that capacitor is to level off the inductive reactance that the chokes the ballasts are putting in from the fluorescent lights to draw them back up to a less lossy level. You can run these fittings without the capacitors installed at all, and they will work perfectly fine. You will see them light up. You won't notice any difference in quality.
In fact, I think there might have been a video on that recently, wasn't there?
Quite possibly, mate. Quite possibly. Goodness knows by this point. But yeah, the point is that the light fitting will work without the capacitor, but it will have to work harder. It will be drawing more current and working harder to achieve the same effect. So if the capacitor has started to fail and is not working optimally, then that light fitting is having to work harder for the same effect. And this is the one here that this is the second one we pulled out. Most of them we just left in, but
so this one, just for comparison, just to see whether they were all playing up or not. So this is 6.47.
So again, the little out of tolerance.
But not quite as much as that. So there obviously was some variability probably due to temperature and amount they're switched on. Certainly that one came from downstairs where it probably was switched on more than the ones up here maybe.
Yeah, and you've got to remember they've been on the job for 23 years, haven't they? So we salute them, salute their hard work.
Yeah. So interesting to see the differences, and maybe just an indication that over time they would have, the power factor maybe drifted a bit more, or maybe we could have had maybe a failure at some point, you never know.
Well, yes, indeed. I wonder what happens to these particular capacitors if they fully dry out. When caps go, they can proper go. I think there's one more thing just to have a little peek at. If you'd like to take that for a moment.
I will. Take my phone.
We have been changing out the LED starters for these fuses. Again, you don't need to. Nobody needs to fuse a 230 volt light bulb. It's just that if you don't stick the fuse in, then you're left with a position, obviously, on the light where you've got to wire it straight through, and a hole in the side of the fitting.
Yeah, which is not good.
So just thought we'd pop one open just so you can see what they look like. And it is...
Yeah, so literally it is a fuse.
Half amp fuse, that's all it is. If one of these lights were to fail in a slightly catastrophic fashion, then rather than it taking out the MCB or going with a hell of a bang or whatever, then it will just take out its local fuse. So it's not a bad thing to have. So yeah, I'm really pleased with how things turned out. Hopefully you are as well, as the customer.
Very pleased as the customer, happy customer. So
definitely have to say that. You can punch me in the face if you want.
Terrible job. Never use them again. No.
Yeah. Don't call me, for goodness sake.
Unfortunately, I had to do the labouring, so that was you know.
You were very good.
I had to
up the tower,
I got very good at passing the right things at the right time on there. So filling in for Linda. So
yes. Get well soon, Linda.
Get well soon, Linda.
Super stuff.
Yeah. So. What have we got left now?
Probably packing away all this bloody cardboard.
Getting rid of these tubes and stuff. And,
get it all on the van. And then each of us has a 2-hour drive down south.
Yeah, we'll be heading back down to hopefully some better weather.
Yeah. Get away from the freezing cold up here. So long, Dewsbury.
Yeah,
thanks for all the meat.
Yeah, mic drop. Yeah.
Back in civilization, if indeed you can describe city electrical factors in Warwick as such. But they do have the means for disposing of our T12s, I presume in some kind of eco-friendly way, and they don't just dump the contents of this container into the ocean. But who knows?
Oh, why do I have to read out the names? I'm a cat, for fuck's sake. I shouldn't have to do anything except lounge around and look fluffy. Fine. Let's get this over with. First up is Andy Hills, who says he'll miss Nigel's cheery face. If Nigel was here, he'd be doing the shouts, and I could get on with my sleeping. But the prick went and left. Next is Andy Kerr-Oosh, who questions why he bothers looking in on this channel. The audio's so painful, I'm sure we all question it, Andy. Mr. Humbug kindly punts in a donation for some tea cut after David's van went off a cliff at the end of the last video. That ought to help buff out the dings. Gimbo79 appears again on the Superwanks and is duly promoted to whore. Congratulations. How proud you must be. Enough of this. I'm not reading any more names. I'm going to go and do a little poo over on the vegetable garden. I haven't got time for this bollocks.